Welcome everyone, thanks for coming to my talk. My name's Damien. I'm the creator of MicroPython, which I started about 10 years ago. Some of you may have seen me give a talk before, and some maybe not. This talk is supposed to be non-technical. There's a few graphs and plots of some data, but otherwise it's mostly just about my experience over the past 10 years. So what is MicroPython? So for some people this is new, and some people it's not. This is just an introduction. Now, MicroPython is two things, micro and Python. Micro is sort of small and also means microcontroller, and Python is, as you know, the language that we're here to talk about. And MicroPython is a complete re-implementation of Python from the ground up. No lines of code are shared with Python. It's a complete a rewrite. And the way it was written was so that it was small and efficient with the resources that you have at hand. So when you're running on a really small computer, a microcontroller, you don't have much memory, you don't have much hard disk space, you don't even have a hard disk, and you don't have much CPU. So there's not many resources at your disposal to do things, but you still want to run a high-level language, in this case Python. And so MicroPython was implemented with the aim to be able to do this, to run Python. You do list comprehensions, for example, and async I/O, to run that in the context of a tiny little embedded microcontroller that may power, for example, a coffee machine. And this started during my time as a theoretical physicist, which was my previous life, and I got sidetracked when I did a Kickstarter in 2013 to bring MicroPython sort of to fruition. It took about 6 months to develop. From April 2013 is when it started, and then the Kickstarter was at the end of that year, and that was quite successful. And then there was another Kickstarter a few years later after that, and then many collaborations since then with various companies and people and institutions and people such as yourself, contributors, hackers, educators who've contributed and used MicroPython. So it's been quite a journey in 10 years, and I didn't really expect it to go where it is today, but I guess I didn't expect anything. If you're asked what's going to happen in 10 years, you don't really have such expectations. But here we are, and I'm just trying to sort of convey the things that have happened in those 10 years with a sort of an aim towards describing what it's like to actually maintain a big open source project. The uses of MicroPython today are pretty varied. So we did quite a bit of work with the European Space Agency to make MicroPython robust enough to run in space. And it's actually used as like a high-level application control language in satellites. The reason there is so that it's easy to update things whilst it's flying, because traditional space-based programming you have in C or C++ or more ancient languages, and it's very inflexible. But these days they want things to be much more flexible so they can update code when it's out there, and it takes 10 minutes or something to actually send data to it. The other things have been in LEGO Mindstorms. So LEGO have used MicroPython to implement their new Mindstorms kits for teaching in schools. Also various commercial products like smart vending machines, various medical devices, vehicle counting and weighing devices on the autobahns in Germany. It's what it's used for. A lung elastomer to measure lung elasticity came out recently. There's many, many applications. Also in teaching, in research labs, people use it to heat up DNA samples and things like this. So it's become quite widely used because it's piggybacking on the success of Python itself as a really easy to use language, and then people who want to build something physical with their hands, like a robot or a toaster or something, they don't necessarily have a software engineering background, but Python allows them to actually program something to make it work. And if you can mix this ease of programming with actual hands-on, make an LED blink and a motor turn, people can make their ideas real in a very a very straightforward way. So that's kind of the key selling point of MicroPython, is it's mixing microcontrollers and the Python language together. You can try it out yourself. There are many, many different hardware platforms that you can get started with. Some of them are very cheap, only a few dollars. Some of them, more expensive. You can run it on lots of different things with lots of different plugins, motors, lights, whatever you like. You can actually try it online in that bottom link there. So if you haven't played with it, it's very easy to get started. Now, this talk is trying to give a bit of an insight into what it's like to maintain a big open source project like MicroPython. I mean, it's not as big as Python itself, for example, or the Linux kernel, but it's still, reasonably sizable project. And there are lots of challenges that come with maintaining the source code, developing the code, and then maintaining the community and building the community around it. Because obviously, you don't really have a project if you don't have people using it, or you can have your side hobby projects, but a project that's out there in the world, the users are really the big part of the project. And we all know this with Python and conferences like this. So the social aspects of software engineering is, I guess, what I'm trying to convey here. I'm a very technical person, and I love working on MicroPython because it's very technical. But as part of that, I've been thrown into this, thing of building a community and doing social sides of computers and technology. And I think it's really interesting and really eye-opening. So also at the end, I'll give a bit of advice if you were ever going to set up your own project, what sort of things you can do at the start to make it easier later on. So I guess the place where I spend most of my day is on GitHub, at this web page or at my terminal, and GitHub is the sort of the nexus of where everything happens. MicroPython is free and open source. So free means you can use it without having to pay, and there's no licensing. It's MIT licensed. And open source means the source code is there and available, and anyone can access it. Those two things are not always the same, and you can have one without the other. But MicroPython is both of those. And you can access the code if you go to this GitHub website. Now, the open source development that we use is, it's based on Git source control. If you're not familiar with this, Git is it changes your way of thinking about code, or at least it has for me, in that code is not about the code, it's about the code you have, but it's also very much about the stepping stones that you make every day to revolve your code from one spot to the next. So a commit is a small stepping stone that you make. Your code has this form, you make a commit and it changes its form. And to me, the commits, the delta, the change, the stepping stones are really the important part, because you can look at them in one go and say, this is what I'm changing, and it comes with a test and it comes with documentation, and this is how the project evolves. And we're very, very strict with commits and how they're formatted and the styling and the commit messages. And I think this is really sort of part of keeping the community on track when it's developing a project. Having a very strict Git history and a strict history of stepping stones allows you to easily track down bugs in the future when they do pop up. So you can go back and use git bisect, which is when you're like, we have a bug, we know that this code is good, this code is bad, so somewhere in here the stepping stone went wrong, and you can easily track it down and then fix it. And it's also good just for people who are new to the project and they want to see, well, why was this change introduced? They can go back in time and have a look, and usually, hopefully, the commit description explains why this change was made. So I think having this really strict Git workflow is really important for us. We have a lot of testing. We've done a lot of work in testing. Part of the work with the European Space Agency was to add a lot of tests to get close to 100% coverage, which is really important. So every line of code has a test associated with it. Now, the coverage is never perfect because there are still many more scenarios than just making sure every line of code is run. But we do have very good coverage, and we are very strict to try and keep that up. And the continuous integration, whenever there's a new commit made, there's a lot of tests that are run automatically, and you have to pass those tests to get that commit in to get that next stepping stone done. So it's a really good safety harness. You can be really confident that if you make a change to the code, even if you don't know what's going on in the whole code base, if you don't break any tests, then probably your code's okay. And by the same token, like you can't just go randomly deleting lines or anything because the test will break. So the test harness is really there as like a safety barrier to make sure we don't do things wrong. Hardware in the loop is something we don't have yet, but we do have offline hardware testing, which is important as well. And the releases, the release cycle is not very strict, but we try and aim for releases maybe every 2, 3, 4 months. And the releases do take a lot of effort because you've got to get to a point where you're confident with the code and you're going to release it and people are going to upgrade and maybe they're going to, the coffee machine's now going to run the new version of MicroPython and you don't want it to break down because embedded system is really hard to debug. So we're very strict to make sure that the releases are quality and known to work and hopefully not have any bugs, or at least no bugs that we know about. Or if we do, we can document them. So the continuous integration testing we have helps us there, but then also there's a lot of hard testing on real hardware before we actually make a release. It's also fun to write the release notes, although that takes me a couple of days of full-time work to actually make a full set of release notes. And it's good because it looks back on the past few months of what you've been doing, and it's like, this is a summary of my life, these release notes. But it's good, and it's nice to make a summary and then put it out to the world and everyone reads it and they're like, okay, I like this new version because it has this and this feature. So this is sort of the day-to-day grind of working on a piece of code. One thing that is really important here is funding. So it's been 10 years since I've been working on this, and you need a source of funding if you have an open source project that is going to live for so long, because you need to live. And you can see here we've got GitHub sponsors, which is a program on GitHub where people can sponsor for like $1 a month or $100 one-off or whatever you like. And that's a continual source of revenue for us now since 2020. And you can see there how much that's in Australian dollars, how much we're receiving from GitHub sponsors. So 2023 is small because it hasn't finished yet. But we get a sizable amount of money there from GitHub sponsors, and that helps to pay sort of 2 part-time maintainers, not myself technically. So, although, yeah, there is a bit left over there, but it is good. The other sources of funding we have are hardware sales. Because it's a hardware software project, we can have hardware that we sell, and some of the money from that can be used to support the development, which is great. But there's also a lot of other contract work that I do, and that other parts of the members of the team do as well. So people come to us and say, we want MicroPython in our product, or we want this feature added to MicroPython, or we want this thing improved. And they pay us to do that work for them. And usually that work that they've paid for goes back into the open source community in the sense that it's not hidden behind anything. It's contributions made to MicroPython that everyone can benefit from. So that's really great that that someone can pay for something to be done. So I can't really stress enough how important it is to have funding, and I think there are a lot of pure software projects out there that find it really hard to get funding and to continue on. There's been lots of stories, about one-man projects that die because that person doesn't want to do it anymore, and then people are relying on this project, so where does it go? So we're very fortunate to be able to continue and to sort of thrive and have enough money to live and continue doing what we love, which is develop this code. The other point to make is about licensing, which is a really deep topic. I have a single line. We use the MIT license. The GPL license is kind of the opposite open source license to MIT, if you want to say that. We steer clear of GPL because in an embedded environment, it's really, not dangerous, but difficult for customers who want to use MicroPython to accept the GPL, because it means that any code they write, like if they're making a coffee machine again, then they have to open source all the code for the coffee machine, which doesn't work. They want to sell a coffee machine, they don't want to have to open source the code for it. So MIT is sort of yeah, the choice that we've made, and I think that was a good choice because it's allowed us to be successful. People use MicroPython because they know they don't have to release their code to the public. Yeah, as I said, it's a big topic, licensing. So the community is very important, as I mentioned before. And in MicroPython, there are sort of these 4 portals where the community mostly can interact with the project. Apart from, well, we also have in-person things, events, once a month at the Hackerspace in Melbourne. But online, there's GitHub, which I told you about before, which is where the code is. There's also GitHub reviews also for discussions, which is like a forum. We used to have a PHP-BB forum, but it was getting a bit old. So we switched to GitHub discussions. We also use GitHub for the wiki. We had a separate wiki at one point, but we again tried to consolidate there. And we use Discord now for chat. We used to use Slack, but we're using Discord. So we have moved around. You know, it's sort of, this is another part. Like, it's not easy to choose a technology to use to interact. Like, we had to make choices here, and some people were not happy with those choices. They were like, we want to stick on Slack, or we want to stay with PHP-BB. But as, you know, the maintainer and of an open source project, you have to make decisions to keep things moving. And there are reasons we went one way or the other to keep up with, you know, the pace of technology and change. But these sorts of things you don't really think about when you're thinking about coding and software engineering. And I don't think, you know, any university course would teach you, you know, how to choose a Wikipedia page or a, you know, a chat interface for all your users. But it's really taxing. And, you know, the team we spent quite a lot of time discussing this and thinking, what should we do? And that takes away from our time. You know, we need to make a living, but do we spend, you know, 10 hours discussing what platform to use? So you have to make decisions about what you spend your time on, and these things you have to be conscious to take up your time. This is a graph here of the monthly contributions to MicroPython over 10 years, which is taken from the Git repository, so all the stepping stones that we've made. The blue and the orange are the commits made per month. So the scale goes up to there to a few hundred, so there's a few hundred commits per month. The blue is the ones made by myself and the few other core maintainers, and you can see that sort of trending downwards. The orange is by sort of contributors who are not the core maintainers, and that is trending slightly upwards there towards the end, which is really great. The green line is actually on the right-hand scale there. That's the number of unique contributors per month, so who've made a commit to the repository. So that's going up as well. So this is a good trend in that the maintainers are doing less commits, external people are doing more commits, and there are more unique people contributing to the project. So that's sort of, you know, that is not without a lot of hard work to foster an environment where that can happen, where external contributors can come in and make contributions to a project, especially one where it's, you know, you have to make sure that the code is still space grade in the sense that it can actually go up in a satellite and run and not crash the satellite. So we have to be very careful about introducing commits to the repository, introducing code changes. And I think it's something to be proud of that we can get to a stage where we have a lot of external contributors. So, you know, we have in a year, we have over maybe 150 to 200 people contributing, and we have around an average of around about 3 commits a day, which is a lot. Like, if you sustain 3 commits a day for a year, over 10 years, that's a lot of work. This here, so this is a plot of the number of people who have downloaded some MicroPython firmware to put on a piece of hardware, like an ESP32 board or something. The different colors are the different boards that, or different ports, but different boards that you can use, different targets, architectures. So the orange line is the Raspberry Pi RP2040, which is a really popular board that came out at the start of 2021. And that's sort of taken off a lot. That got a lot of popularity. The blue line just below it is ESP32, which is Espressiv's new Wi-Fi board. Well, not that new, but you can see that started around 2017. The green was their previous Wi-Fi board, the ESP866, which started off earlier than that. And the red is then STM32, which is the PyBoard's architecture. So this is showing, obviously, that we're having more users, or at least more people downloading. But hopefully, it's a good indication of users. So downloads per month. So we've had over 3 million total downloads in. So this is 8.5 years because we didn't start downloads, immediately. So this is showing that the community is definitely, people using it is growing, and the previous graph is showing, people contributing to the code, the way that's trending. So building a community, it's really hard, and people have to do, marketing, branding, website maintenance. I don't really like doing those things, but you have to do them anyway. Some people are very understanding when they're part of a community, and they're like, yes, I understand that this is your time that you're spending on this, and that's really great. Some people are less understanding. Most people have good intentions, but sometimes people just don't understand and get stuff wrong or get confused and are rude and say, oh, this doesn't work and it should work and this is a terrible project, or they get the bad end of the stick. They come to some corner of MicroPython that's just not well tested and doesn't work, and it gives them a bad impression of the entire thing. So there is a lot of varied sort of interactions that you have, and people have different experiences. For example, to make a bug report, people are supposed to tell you what the bug is and make it so help you to fix it. We have an issue template where if you want to submit a report, there's a template that you fill out. We added that so that people would actually give good bug reports, but it's been almost completely ineffective. People basically just delete the template and write whatever they want, and usually don't even say what version they're using, what hardware they're using. This like, my Wi-Fi doesn't work. And you're like, the complete loss to help them, because there could be so many reasons why the Wi-Fi doesn't work. So some people, most people have good intentions, but usually the good people are the people who don't say anything and are just quietly understanding. The people who don't understand are the people who take your time and you need to help them. Well, you don't need to, but you choose to. It's important to set expectations, but people rarely read documentation or anything, so even if you have a manifesto, people are not going to read it, and they're just going to behave the way they do anyway. And some people, well, a lot of people with MicroPython come to it to try and learn, like, how do I turn an LED on and how do I blink an LED? And then they get stuck, and then they ask for help, and this is great, we're teaching people here, but who has time to help them? Do you take it out of your time to do that when you have other pressing things to do, to write code or to maintain a website that's crashed or something? So you really have to decide where your time goes and what you want to do. And with a big community, hopefully there are other people that can step in when the questions are simple. And as a maintainer, you're needed for when the questions are really hard or there really is a deep problem to solve. So I think one of the main points is that as a maintainer, it's important to make sure that there's direction and that people don't get lost and be like, oh, there's no decisions here, everyone has different opinions, and we don't know what to do. So it's a maintainer's role really to set the direction, to say, out of all these choices we have, we're going to choose this one because of this and this. Some people are going to be upset, some people are going to be happy, but at least there's a decision made and we can move forward. And then people can deal with the decision and say, okay, well, this is how it works, and I will work around that. But if you just let it sort of flounder and there's no direction, then that's really not a good way to run a project. But it is very rewarding. I mean, there are times when it's tough and you don't want to open your email because there might be emails that are people, not abusing you, but it's not really nice to read responses sometimes. But then there are other times when you get really nice replies from people, or thank you, it's a great project and things work really well and I've used it for this and that and it's really helped me a lot. So it is very, very rewarding when things work. A lot of people are thankful and grateful, which is nice, and there are definitely some standout community members that help and go out of their way without asking them, and they help to foster the community, answer questions and be there all the time, which is really great. And as a maintainer, you have to recognize those people and the people who have expertise and are willing to help and really allow them to do their thing and foster them and foster their activities and say, yeah, well, just step back and let them do what they do well. And also, I ask people when I don't know something, I ask them and I say, you know more about me than this topic, so can you please help? So that's good. This is an obligatory AI-generated image. It's such fantastic technology, but anyway, this is just to show you. The next bit is about bug reports and contributions. So, as I said before, bug reports, some people do not give very good bug reports because it's not reproducible. If you're going to give a bug report, please make it reproducible, and then at least someone can try and fix it. But then on the other side, there are contributions, a pull request, someone who has an idea about how to change the code, and they're like, I would like to change the code this way. And when someone makes a pull request, you're like, okay, here's another 10 hours of my life gone. Because a pull request, that was joking in a way, but a pull request is a lot of work to go through. Sometimes it's a few hours reviewing the code, giving some feedback, and then they go back and forth for maybe a few weeks where you say, this has to change, has to be tested, you review the code again, and eventually it's good enough to merge, and then you go through the last little details of making sure the commit message is right and all the tests pass properly, and maybe the CI broke down a little bit, so you have to fix that. And it takes a lot of time to get a contribution from someone in. And that's not to discourage contributions, because they're obviously what make the project work. But as a maintainer, and if you maintain or one day maintain a project, you have to be aware that you need to do a lot of work to foster people, foster the community, and get the code in and get it working. Sometimes it's easier to do the work yourself and just say, okay, I know how to fix this, I'll just do it. But you can't do that forever. So you really have to learn how to get people efficiently contributing to the project. And one thing we do down the bottom there is we try and automate as much as we can in terms of contributions. So people will have a pull request, and it will go through the code formatter and spell checker and code styling, and even commit formatting and making sure they've signed it off and everything. And those things are all automated, so we don't have to worry about that. And people can check their code formatting, make sure it is correct, fix it if it's not. And once all those things pass, what's left is to review the actual code, which is the meat of the problem. One thing to mention is that sometimes you get sort of lost in a conversation or a heated argument or a discussion or something about code, and I think a lot of us have probably been there. And one good thing to try and do is to distance yourself from the actual personal interaction and talk about the code rather than the people. And instead of saying, why does your code do this? You say, why does the code do this? So don't talk about the person's code, you just talk about the code. And that removes the sort of human. There is human element there, and that's important, but when you say code doesn't work, it can almost feel like an attack on someone who wrote that code. So instead of saying, why doesn't your code work, why doesn't the code work? So some maybe take-home points about what I've learned. It's hard to maintain an open source project. It takes a lot of effort. But I'm still here after 10 years, and I still love the technical side, and the community side is really great. It's really rewarding. You can't please everyone. There are always people who will think that you've made a bad decision, but you just have to go with it. If you're passionate and just follow your instincts and have some nice sort of like a manifesto or a goal or a real overarching principles, in this case, it's MicroPython, so microcontrollers and small and Python. So we've got to try and implement Python, but we've got to do it in a way that's small. So we're not trying to re-implement Python. So when people say, oh, it's missing this and this and this, and we need that to match, I'm like, we can't, because it won't work then. Like, it won't work on a microcontroller. So we have these two pillars, micro and Python, and we have to make sure we follow those for all the decisions that we make. So I think we're very fortunate to have a project that has strong ties to hardware and software. So it's a real physical thing. You can make something, and it's also a software technical project, and that really gives a good balance. And funding, as I said before, if you want to do a project long term, you really need to think about how you'll fund the project. Maybe you can do it in spare time, but in this case, the project is large, and we have multiple maintainers, and some people working on it, and that's the only thing they're doing. So we need to be able to pay people to do that. If you're going to set up a project, I suggest you choose your license from the beginning, write a code of conduct, pick a Git workflow that you like and stick with it. Make sure you have a nice directory structure so you don't have to move files around at the end. Version well from the beginning, hopefully using Semver if you don't read about it if you don't know. Have some really good code formatting and linters and things set up from the beginning. Choose, pick black as your Python code formatter and Clang format or something else. And stick with that because that will really help you from the beginning. And then I think it's just some final words that I think sum up a lot of the time during the day when I'm working. I feel like this is that when you put yourself out there online, when you've made some code, or when you make a change, or when you make a comment or a post in a community, you're really putting yourself out there. And that's hard because you put your person out into the world. And when you're maintaining an open source community, I think you have to be aware of that and foster an environment where people are comfortable to put themselves out. So when they put up a piece of code to review, you realize they maybe put a lot of time into this. Or they've made a bug report which is really detailed, and they've put themselves out there. So if we have a community where people are comfortable to put themselves out there, you can build that community up and make it a really nice place to live, to live online and to work. And I hope that's what we've done with MicroPython over the past 10 years. It's fostered a good community where we have members who enjoy being part of it. Because yeah, I do, and I think it's been a very rewarding 10 years so far, and I hope that there is more to come. There definitely is. So thanks for listening.
Thank you very much, Damien. We have time for one quick question. If anyone would, okay, yeah, I think we'll go for the close one. Sorry.
Thank you.
Thanks, Damien. How have you engaged people to, assist you with testing on, I guess, the variety of hardware and applications?
Yes, that's a good question. We have automated testing, which is obviously people don't have to work with, but for hardware testing, there are community members or people who do that when there's a pull request or a commit for a particular piece of hardware that I may not have or that may be difficult to test. Other people will test it. You can just at them on GitHub and say X, can you please test on your hardware? And they do that, and that's great. Yeah. So there are people who will test on various pieces of hardware for us.
And applications? Sorry,
applications.
Applications?
You mean?
So people have got MicroPython applications.
And how do they test them?
Yeah. Is there any pre-release testing?
I have a few private applications that I do tests on before we make a release to make sure that they're still functioning, and they do good integration testing of the whole system. Yeah. Usually people will test the non-release code, like before we make a release. Like they'll be like, oh, we want to use the latest MicroPython because it has a feature that we need, and they'll test it on their project, and then there'll be a bug report the next day about how something broke, and we fix it. So it is a really continuous process. There's always generally a lot of testing from other people, which is very helpful.
Thank you.
Great, thank you so much. And here are your speaker gifts. And
thank you very much
for presenting today.
Thank you.
Great. Thank you.